Hi, this is Santosh, and this is the Sparks Foundation internship task 3. So I've completed task 3, and this is unsupervised machine learning. The data is iris data set, and I'm using k-means clustering over here. So let's begin. So I've imported the necessary files, NumPy, Matplotlib, and the pandas. To start with, I have downloaded the data and then used Google Drive, where I've uploaded the iris data set, and from there I am accessing the data. And then I've tried to picturize the data over here by using the head function. You can see the first 5 rows. This has 6 columns altogether, which out of which 5 are the features, and the sixth one is the label. And further, I'm trying to understand this data. There's 150 columns, 150 rows and 6 columns. Okay, over here you can see the type of data set, the type of data for of the columns, integer, float, and the last one is object. A little bit of description to see the mean of each variable, and the max and min, okay, which will help you to further use it in the model. Let's try to check here the missing values. There are no missing values. Okay, so let's go further and prepare the data. Over here I'm trying to I've dropped the first feature, which is id, which is quite irrelevant, which is as same as the index. And then I have used ilog function to grab the rest of the feature, excluding the last one, which is target. And in this way I'm converting the data set, the data frame, pandas data frame, into a numpy array. Okay, and this is required for to visualize the clusters, okay, in the future, in the further coding. So to find out the number of clusters, I have used the elbow function, okay, with the help of the algorithm k-means. Over here I've used for function, for loop, and try to find the inertia, and I've plotted the inertia of from the k-means algorithm. And over here we can see the elbow is at number 3, so we need to have 3 number of clusters. And so I have implemented the same, and I have predicted using k-means fit underscore predict. So yk-means over here is the prediction. With yk-means I try to visualize the clusters, and this is how we end up with 3 clusters over here, you can see. And I have labeled them as Setosa, versicolor, and virginica. I have also spotted the centroids for each one of them. Now that's what the objective was, and this is where we complete the task. However, I've gone further and tried to use PCA in this task once again. And PCA is usually people try to use the sklearns PCA function, but in that there is one um, question mark which still uh, people have no answer to, is how much component to be used. Now, hence, because of which I have tried to code a manual PCA to find out the number of components. Over here, what I've done here is try to find the covariance matrix of the dataset X, which does not include the target, and then separate the eigenvalues and vectors out of it. And then further I have tupled both the values, eigenvalue and the vector together. And over here you can see um, I have the output in the descending order, okay, and this is the absolute value. Okay, so what I'm trying to do here is try to find the variance, explained variance, or we can say the variance which is variance explained, to check what how important the components of the PC, the principal components are out of the 4. So if we see here, The first component itself carries 92.46%, and the second one is 5.3%. So just the first two components, principal components, make more than 95% of the importance of the data. So what I've done next is I have used the cumulative variance explained over here to show that, if you accumulate the importance, the first one is 92, with the second one it comes to around 97.76. And then further, I have made a matrix W, okay, which will help us to uh, visualize the data accordingly. And then I've used the dot matrix feature here to make two columns of in the array. Okay, here again I am label encoding the target feature so that we can use it in the visualization. Okay, and here this is how I've visualized using the matplotlib scatter plot. Okay, and also labeled the data. So this is how I've used a PCA manual for the iris dataset to cluster. I'll also show you how simple it is to use the sklearn's PCA function. This is where I have imported the PCA from sklearn decomposition and iter2's cycle, and I'm directly using the PCA function here with component 2, and then same uh, vector, same numpy array that we got it over here is what we get directly from PCA. It's a shortcut. Okay, and then I have used the function called PCA components underscore to see the components here. Next, what I'm trying to do is trying to find the PCA explain variance ratio, the same thing that we did it in the manual. Over here, we have a ready-made function which we can directly use it, and this shows the sum of the two components at 97%, as we did it earlier as well. And then I've plotted the scatter plot with the same. All right, so this was again a fun task, okay, and I did enjoy, and I hope you did too. You can find the link to this workout that I've done on my GitHub. I will leave my GitHub link at the bottom of this video. Thanks and enjoy.